Hello, just want to welcome everyone as you file in. Let you know we're going to get things going in about another minute from now as we take a little more time for everyone to get situated. But again, we thank you for joining us. Once again, thanks for joining us for today's webinar. Going to allow about another 30 seconds for people to get filed in, and we'll get going in that time. Okay, an official hello, everyone, and welcome to today's Safety and Health Magazine webcast, Preventing Serious Injuries and Fatalities, How Technology is Reshaping Workplace Safety, sponsored by Cority. My name is Kevin Drewley. I'm an associate editor with Safety and Health Magazine and will be moderating today's session. Thanks for joining us. In a few minutes, we'll start our presentation, but first let's review some preliminary items. The views of today's speakers and organizations are their own and may not necessarily reflect those of the National Safety Council or Safety and Health Magazine. Any mention of a commercial enterprise, product, or publication does not necessarily mean the council or magazine endorses those items. At the end of today's webcast, we'll conduct a question and answer session. To ask a question, simply click the Q&A button at the bottom of your screen, type your question, and click the Send button. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded along to today's speakers. At the end of the webcast, you'll be asked to complete a brief evaluation survey. We'll let you know more about that after the presentation. This webcast will be archived so you can access it after today's live event. To view this webcast and all of our past webcasts, please visit safetyandhealthmagazine.com/events. With that, let's go ahead and get started. Our speakers today are Farzhana Shah and Tanya Jenke of Cority, who will share more about themselves momentarily. Again, we thank you all for tuning into this presentation. Farzhana, whenever you're ready, go ahead and take it away.
Great. Thank you, Kevin. Hello, good morning or good afternoon to everyone joining us from wherever you are. Thank you for taking the time to be here with us today. My name is Farzhana Shah, and I'm a product marketing manager at Cority. I'm thrilled to welcome you to our webinar on preventing serious injuries and fatalities, how technology is reshaping workplace safety. So why did we feel this topic was important? Well, because despite decades of progress in workplace safety, serious injuries and fatalities, or what we call SIFs, remain stubbornly high. These are life-altering or life-ending events, and they demand a different approach than what traditional safety programs have offered. So over the next hour, we'll explore why SIFs persist, what makes them different from other incidents, and how technology is helping organizations like yours move from reactive to proactive safety strategies. We'll also be sharing practical tools and frameworks that you can start applying right away. Before we dive in, just a quick reminder that we will have that Q&A session at the end. So please use the Q&A panel to submit your questions as we go. But we'll also be running a couple of quick polls throughout the session to get your input on a couple of questions. So to get us started, these are the topics that we'll be covering today. So first, we'll be starting with an overview and maybe a refresher for some of what SIFs are and why they matter. We'll look at some global data and trends that highlight the urgency of this issue. Next, we'll dive into the core elements of an effective SIF prevention program, what makes these programs different from traditional safety initiatives, and why focusing on SIF precursors is critical. Then we'll explore the role of technology, how tools like mobile solutions and data analytics are transforming the way organizations identify and control SIF risks. Finally, we'll wrap up with that Q&A session where we'll answer your questions. So by the end of the webinar, you'll have a clear understanding of why SIF prevention requires a targeted strategy and how technology can help you achieve it. So moving on, we'll just do a quick introduction of your speakers for today. As mentioned, my name is Farzhana, and I'm a product marketing manager here at Cority. For those of you who are not familiar with Cority, we are a software company that provides software for EHS and sustainability solutions, and we service thousands of customers in different geographies and industries around the world. We work with EHS professionals like all of you on some of their most challenging issues, and we help them address those issues with technology. I myself am an environmental engineer by training and am a registered professional engineer in Canada. I spent nearly 25 years working as an EHS professional, primarily in the oil and gas industry, and I joined Cority late last year. My passion has always been about making workplaces safer and helping organizations adopt innovative solutions to achieve that. I'm thrilled to be joined today by my colleague, Dr. Tanya Jenke. Tanya brings a wealth of experience in safety leadership and has worked extensively with organizations to implement data-driven safety programs. Tanya, please go ahead and introduce yourself.
Thanks so much, Farzhana, and thank you to the NSC for having us. I'm so happy to be here today. My name is Dr. Tanya Jenke, and I'm the Director of Customer Success at Cority. I have a deep passion and curiosity for why workers are injured. And this passion has led me to my work in occupational health and safety for over the last 2 decades. I am a certified safety professional, both within Canada as well as in Australia. And I've spent the last few years completing my PhD in occupational health and safety, where my research focused on the impacts of external factors on safety performance. I love being able to spend my time researching and understanding why injuries occur and bringing this knowledge into my work at Cority as well as to today's webinar.
Awesome. Thank you, Tanya. So together, we hope to bring both of our knowledge and experiences to guide you through today's discussion on how technology is reshaping sick prevention. So we're ready now to jump into the first topic, understanding serious injuries and fatalities. And Tanya will lead us in that discussion. Over to you, Tanya.
Thanks, Farzhana. So let's start by setting the context with some data. Globally, there's nearly 3 million workers who lose their lives due to workplace incidences each year, and over 395 million workers experience injuries. In our very data-heavy industry, we find ourselves at an inflection point where we can leverage this wealth of information to improve safety outcomes. Over the past few decades, we've seen significant reductions in overall workplace injury rates, thanks to stronger regulations and improved safety programs. However, when we look at fatality rates, the story is very different. The chart that you're seeing on the left displays data from the US, the UK, as well as the EU. And you can see that while minor injuries have declined, fatality rates have plateaued. And in some regions like the US, we're even seeing an increase. This is a critical insight because the strategies that worked for reducing minor injuries are not enough to prevent serious injuries and fatalities. And the research has indicated that hazards that injure people are simply not the same as those that kill people. So what does this mean for us as safety professionals? It means we need to rethink our approach. Up until recently, safety professionals have relied on Heinrich's pyramid theory of incidences to drive safety strategies. However, fatality rates oppose this theory. The Heinrich theory suggests that serious incidents share relatedness to lower severity incidences due to similar underlying organizational weaknesses. In essence, it implies that resolving these lower severity events would prevent more serious injuries. However, we've learned that this model was imprecise in predicting severe or fatal incidences because it's really only a narrow subset of less severe incidences that had the necessary conditions to trigger a serious outcome. And additionally, it's time to move away from using total recordable incident rates as a measure of safety performance. The research has demonstrated that TRIR does not predict future outcomes effectively. And as a profession, we need to focus on more meaningful statistics that truly reflect the dangers that are inherent in workplaces. To prevent serious outcomes, we need to identify events and activities with serious injury or fatality potential and ensure that our strategies are aligned with the true risks that we actually face. By utilizing the right data, we can reshape our approach to safety and work towards a future where all workers can return home safely at the end of the day. Next slide, please. So let's take a moment to discuss why the topic of SIFs is so crucial for both us as safety professionals and more broadly for organizations. A recent survey by Verdantix showed that by reducing serious injury and fatality incidents, this is the top operational priority for many organizations worldwide. And this really highlights that leaders are not only aware of the serious human toll these events can take, but they're also thinking about the financial implications. While us as safety professionals are dedicated to saving lives, there's also a broader organizational impact. Companies that prioritize safety often find that they're more resilient. They're more able to adapt to changes in their external world, whether those be economic shifts, new legislation, or even global events like the pandemic. Organizations that consider external factors are more successful. It's clear that organizations are seeking solutions that push beyond just meeting compliance standards. The same survey points out that organizations are increasingly focused on using leading indicators for proactive safety management. But what does that mean? Unlike lagging indicators like injury rates, which occur only once the event has happened, leading indicators are all about predicting and preventing incidences before they happen. And this proactive approach can really change the game. Technology plays a pivotal role here, offering us real-time data, predictive analytics, and a clear view of high-risk situations. Before we dive any deeper, I'd love to see how familiar everyone is with the concept of SIF precursors. And thanks for popping this poll up here. The question is, how familiar are you with the concept of SIFs? So we'll just wait for a few minutes for everyone to populate their answers and we can see what everyone is saying. All right, that's amazing. 41% are very familiar, 31% moderately familiar, 21% somewhat familiar, 5% not familiar, and 3% I'm here to learn more. Great, great to hear. Okay, let's look at the next slide now. So this is a refresher for everyone, since many of you, really happy to hear that you're so familiar what SIF events are. And for those 8% that are here to learn, you're in the right spot. So for us, SIFs are not just statistics. They represent real work events that can be life-threatening, life-altering, and even fatal. On the flip side, we have PSIFs or SIF-Ps, which refer to incidences that have the potential to lead to serious consequences. To reduce the chances of a SIF event, organizations must identify as well as intervene, focusing their efforts and resources on situations with the highest SIF potential. And identify those situations with the highest SIF potential, we need to determine where the SIF precursors exist. So SIF precursors are generally defined as a condition, if left uncorrected, could lead to a serious injury or fatality. And SIF precursors typically consist of 3 distinct elements. The first element is a high-risk situation. Since every individual perceives risk differently, what's considered high risk can be somewhat subjective. So how should firms identify what is high risk? To address this issue, many organizations have adopted a more energy-based approach to classification, where the magnitude of potential energy transfer is the primary means to categorize situations as high risk or not. In this respect, what makes the task particularly risky is an individual's potential exposure to high, uncontrolled energy. For example, let's say we're looking at someone who is working from height. The potential energy transfer, if that individual falls and strikes the ground, is large, and therefore is the basis for classifying this particular task as high risk. Conversely, if we think about slips and trips, these generally involve lower energy and are therefore not considered high risk. When we're looking at whether things are high risk or not, we also need to consider the effect of risk amplifiers. These are conditions or situational factors which may increase the potential for high energy exposure or the severity of energy transfer. Things like weather conditions, productivity pressures, changes in work scope, fatigue, any one of these factors could amplify an individual's exposure to hazardous energy. For example, if you take a worker who's working at height in poor weather conditions, this could increase their risk of falling due to slippery surfaces. Also, if we have untrained workers completing hazardous tasks in a very fast-paced and demanding work environment, there's a higher potential that they might be injured. The key is to identify where high-risk situations exist so the organization can begin to focus their attention as well as their resources on what control measures are required to protect workers from a high energy exposure. So element number 2, once we've identified those high-risk situations, we need to assess the presence and effectiveness of control measures which are needed to prevent or mitigate energy exposures. SIF potential increases when we have a known high-risk situation and where required controls are either not available, not effective, or not followed. And when it comes to control measures, not all controls are created equal. While preference should be given to those controls that sit higher on the hierarchy of controls, SIF prevention models particularly emphasize the use of critical controls. Now, critical controls are measures that are specifically targeted to prevent or mitigate exposure to high energy sources when they are installed and used properly. For instance, a fall arrest harness is an example of a critical control, since it directly prevents an individual from striking the surface below them if they fall. This will happen even if the individual makes an unintentional error. In contrast, the use of warning signs to alert an individual of an open edge is not considered a critical control, since it's not resistant to human error. Someone could easily ignore the warning. And finally, element 3, where high-risk situations exist without adequate controls, the last option is to prevent a SIF is to intervene, to stop work, and demand correction. If high-risk situations without direct controls are allowed to continue, the risk of a SIF grows. The likelihood of an unmitigated situation continuing is directly influenced by something that we as safety professionals can control: organizational culture and leadership commitment. Overall, SIF prevention activities focus on identifying and addressing SIF precursors in the workplace. So what exactly does a SIF prevention program entail? And specifically, what activities are included? So while models and approaches differ across industry sector, initiatives generally focus on 3 elements for an effective SIF prevention program. The first element concerns the identification of high energy and risk amplifiers. Like most activities, the first step in preventing an undesired outcome is to identify the hazards and then assess the risk that they pose. In SIF prevention programs, we are specifically focused on identifying high energy hazards that indicate a high risk situation. Beyond identifying hazardous energy, we are also concerned with identifying those risk amplifiers. So as mentioned earlier, they could be weather conditions, they could be fatigue, or it could even be something like risk normalization, which is the phenomenon where risky behavior is gradually accepted over time. Any one of these factors can amplify an individual's exposure to hazardous energy. After high energy and risk amplifiers are identified, we need to validate in-field controls. Organizations should then shift their focus to validating that the required controls are in fact installed as well as effective. And this can all be done through in-field observations. Where direct controls are found to be missing, ineffective, work must cease until those controls are reestablished successfully. Corrective and preventative action may be required to return control measures to their desired state. And lastly, we have post-event classification. If an undesired event occurs, the incident must be promptly reported, investigated, and appropriately classified to allow the organization to identify the degree of CIF exposure and the degree of control present that helped either mitigate that exposure or allowed that exposure to occur. CIF classification helps the organization assess the effectiveness of its CIF prevention efforts and prioritizes actions to address potential future CIF exposures to the greatest extent possible. And now we have another poll question.
Hey, thank you so much, Tanya. Okay, so we've just got some really great grounding and refresher on CIFs. And we just also learned about what should be included in a CIF prevention program. So we're just going to take another quick poll of the audience to see where all of you are on your CIF journey. So for those of you that are here to learn about CIF and answer to such, in the first poll, please free to also engage here with this question. As you'll see, there is a response that applies to you as well. So the question is, where does your organization currently stand with implementing a CIF prevention program? So your options are, we have implemented a program and are continuously improving it. We've recently started implementation of a program. We're exploring the idea, but haven't started yet. We haven't considered it yet, or we're partnering with others to develop or enhance our approach. Just give everyone just a few seconds to reply. Okay, that was great. That was pretty quick. Okay, so just like the first question, a lot of you are here probably with some mature programs, but there's a good portion. So 30%, 37% have implemented a program and are continuously improving it. We've got 15% that's just recently started implementation of a program. And then there's a good 33% that are exploring the idea but haven't started yet. 13% haven't considered it yet, and then there's 2% that are actually partnering to develop or enhance their approach. So a really great mix. So yeah, no, really great to have all of you experienced folks on the call as well. So that's great. Thank you for participating in that poll. Okay, so we will move on. Okay, so we're going to move on now. So we now understand that what CIF events are and what is included in a CIF prevention program. We're now going to dive into some of the actual tangible tools that have been developed to support the 3 elements of a CIF prevention program that we just covered. We'll then be transitioning to how digital technology can be leveraged to enhance the outcome of those tools. So many sectors, including the NSC, have begun to develop models, frameworks, and tools to provide some guidance and standardization to organizations in their respective industries on how to effectively design, implement, and manage their CIF prevention efforts. One specific leader in this area that we wanted to reference today as a really good use case is the Edison Electric Institute, or the EEI, which is an association representing investor-owned electrical utility providers in the United States. So several years ago, the EEI partnered with the Construction Safety Research Alliance, or the CSRA, at the University of Colorado Boulder to develop specific processes, methodologies, and tools to help utility companies, given their high-risk nature, create and sustain the necessary components of a CIF prevention program. But you'll see that these tools are not just applicable to the utility industry. They can apply across any industry that carries CIF potential hazards. Here, we're going to be reviewing some of the processes and tools that were developed through that EEI and CSRA partnership. So first, under the category of high energy and risk amplifier identification that Tanya introduced earlier, the EEI developed its Energy Wheel, which is a graphical tool of icons to remind workers of the common energy sources that should be considered during pre-task hazard identification and risk assessments. Of course, we'll be showing you what this tool looks like in the coming slides, but where high energy sources are identified, the direct controls to mitigate exposure to that energy source are required. The EEI also developed its CIF Precursor analysis tool designed to help workers identify applicable risk amplifiers present in their environment and discuss how those amplifiers should also be effectively mitigated to lower the risk of a SIF event. For in-field controls validation, the EEI and the CSRA jointly developed their High Energy Controls Assessment, or their HECA tool. With HECA, organizations conduct in-field observation of work in progress to validate that the required direct controls that were identified during the pre-task phase are both present and effective. The process generates a HECA score that serves as a really good leading indicator of SIF prevention success. Note that some organizations may also call this critical controls validation, where essentially the term critical controls is used synonymously with high energy controls. And finally, under post-SIF event classification, different organizations and industries apply specific methodologies to classify incidents for their SIF potential when an unplanned event does occur. But irrespective of the model that is used, it should be designed to ensure objectivity and to reduce bias. The EEI's safety classification and learning model leverages a decision tree approach to help organizations consistently classify events for their SIF potential based on responses to 4 simple questions. 1, was a high energy present? 2, was there a high energy incident? 3, was a serious injury or fatality sustained? And 4, was a direct control present? And depending on answers to these questions, organizations can classify incidents as either a SIF event, a potential SIF event, an exposure where a high energy release was present, but a direct control was missing and there was no injury and there was no resulting injury, or a capacity where a high energy release was present and a direct control was in place and it was effective. Each of these processes and tools enables organizations to calculate, collect, and monitor specific leading and lagging indicators to evaluate the efficacy of their SIF prevention efforts, and then to identify priority areas for further intervention and resourcing. So we'll now transition over to how technology can support our SIF prevention efforts. And Tanya will introduce us to that topic.
Right. So we know from that poll that many of you on the phone and many organizations have taken significant steps towards addressing SIF prevention. Many of you already have a program in place and you're looking to continuously improve it. Many of you are also starting out fresh. So hopefully the tools that we talk about now here in the role of technology will really assist in your journey. So there's a challenge here. And really what it is identifying the steps that we need for a critical SIF prevention program. How do we operationalize them? And this is where technology becomes a game changer. It gives us the tools, the data, and the insights to make informed decisions in high-risk situations. Technology ensures that workers on the front line, those in the field, have the support they need to minimize the SIF risks when they arise. So how exactly does technology and specifically software help in this mission? Well, I'm proposing 4 key areas where technology is revolutionizing SIF prevention. And the first one is safety management systems. Right. So at its core, safety management systems is all about integrating safety policies and processes into a seamless, comprehensive framework. With the right tools, organizations can implement a SIF prevention strategy that supports effective risk detection, prioritization, as well as mitigation. Imagine an organization that doesn't have standardized systems in place. How do they ensure accountability? How do they make sure that the processes that they implement today are repeatable tomorrow? Well, software application can solve these challenges. And what this does is this integrates related processes into a single system, driving firm-wide standardization. This ensures that SIF potential is not only detected, but also addressed consistently and reliably. And here's the result: improved safety performance and a stronger foundation to longer-term success. We know that keeping up with external standards is key to learning about new developments in the standard processes. And this is where technology can support achieving SIF reduction. In addition to the already published guidance and tools Farzhana talked about through the Edison Electric Institute and the Construction Safety Research Alliance, ASTM is about to release their new guides for recording SIF events. And for anyone who was in Denver in September, you may have attended one of these sessions discussing this in further detail. All of these standards can be incorporated into your safety management system and can provide clarity to your employees on how to follow them. The next item is data analytics and predictive modeling. Organizations often collect massive amounts of safety data, but here's the problem. Many rely on manual processes that are too slow and inefficient to support critical in-field decision-making. And this is where technology truly shines. Modern software tools enable safety professionals to unlock their full data. They can analyze patterns, identify trends, and detect SIF precursors, those high-risk situations that require immediate attention. For example, imagine being able to predict areas where risks are rising based on your own historical data, and then directing your resources to prevent incidences before they occur. This isn't just reactive management, it's proactive risk prevention. The power of the data lies in its ability to highlight organizational blind spots. When organizations can see the big picture, they minimize surprises and fatalities become far less likely. The next item on here is real-time data monitoring and response. And this is enabled by the Internet of Things, or IoT, which has revolutionized workplace safety by introducing sensors and devices that can monitor asset, systems, processes, and even environmental conditions in real time. And how it works is sensors are installed to detect anomalies, things like gas leaks, temperature fluctuations, or equipment malfunctions. The moment an anomaly is detected, the system will trigger an alert, allowing workers to take immediate preventative action. For example, let's say we imagine a manufacturing plant where a machine starts overheating. A sensor could identify this issue and send a real-time alert to nearby workers. Action is then taken immediately, preventing not just the equipment damage, but also potential harm to employees. And this is the power of technology. It doesn't just warn us about risks, but enables us to eliminate them in real time. And the final piece is engagement. Technology, especially through mobile access solutions, has opened up many opportunities for engaging workers and enabling where they are. Mobile solutions, for instance, allow organizations to deliver critical safety information directly to the workers at the moment when they need it the most, at the point of decision. So imagine a worker who's recently received instant guidance on site. This will ensure that they have all the information that they need to prevent an incident. At the same time, the mobile tool gives workers the ability to share their insights and concerns directly from the field. This two-way communication informs future SIF prevention strategies and helps the organization make smarter investments. The result? A stronger connection between leadership and frontline workers, and a workforce that feels empowered to actively participate in safety initiatives. Where everyone's engaged, safety becomes a shared responsibility, and the results will speak for themselves. The message is clear here. Technology isn't just a tool, it's a catalyst. It takes SIF prevention strategies from theoretical to actionable, making workplaces safer and saving lives. As we look to the future, it's critical for organizations to embrace those technological advancements, and by doing so, they're not just preventing tragedies, but they're building a culture of safety and innovation that benefits everyone. And now Farzhana is going to take us through some more areas where we can leverage technology.
Yeah, exactly. So now we'll just go through and actually bring this all together and talk about how all that technology goodness looks like, what it looks like in the field. How can we make it actionable and practical for everyone to use? So far we framed the three elements of a SIP prevention program, and we have an idea of where we can leverage some technology tools. We're now going to dive into where some of our specific SIP prevention tools that we talked about, and where we can leverage that technology to improve those outcomes. So if we go back and we look at the first element of a SIP program that we talked about around high energy and risk amplifier identification, let's look at these tools in more detail. So what you see on here on the left is that energy wheel that we referenced. And as we mentioned, it's a simple visual way to anchor pre-task discussions around where high energy exists. So you'll see things like gravity, electrical, mechanical, and chemical energy. So the idea here is really straightforward. If we can help our frontline teams quickly spot uncontrolled or poorly controlled energy sources using this tool, we can dramatically reduce the likelihood of a serious injury or fatality. And some organizations will take this visual and create laminated cards or posters. And these can definitely be useful, but they do become a passive tool. By digitizing it, we can make it interactive and contextual at the point of work. A checklist like the one shown here on the right can be created with digital workflows where crews can visually see the energy wheel and choose the energy type in a drop-down menu that are relevant to the job that they're about to do. For example, choosing gravity for working at heights or mobile equipment for yard operations. A digital tool can then prompt for direct controls as part of the pre-task assessment by asking questions like, is fall protection present and effective? Or is the equipment to people plan separation in place? We can also surface risk amplifiers with a precursor analysis tool, as seen in this specific example on the right. Things like time pressures, changing scope, weather, or fatigue. These can tip a routine task into a high-risk exposure. The checklist and workflow are built to make sure that we're not just identifying energy and risk amplifiers, but we're also validating whether critical controls are available and used prior to conducting any work. Think of it as closing the risk loop. We identify the high energy source, we identify any amplifiers that could elevate the risk, and then we confirm that direct controls are in place. In a digital workflow, those answers can also be supported with photo verifications, or if a control is missing, you can build in rules to trigger a stop work prompt and escalation notifications. The real power here is that these pre-job assessments are no longer just paperwork. They become data. Aggregated across jobs, sites, and contractors, they can show patterns where energy exposures concentrate, which controls are frequently weak, and which risk amplifiers show up before incidents occur. Over the next slides, we'll be looking at how we extend this digital thread into our in-field control validation with the HECA tool and into post-event classification with the safety classification and learning model, so that everything will connect from hazard identification to learning and improving. Okay, so once we've identified our high energy sources and potential amplifiers, step 2 is to verify on the job that the direct controls that we planned for are actually present and working. And that's what the high energy control assessment, or the HECA tool, is built for. Many organizations start with HECA on paper, where observers check boxes or maybe add a comment, and then the form goes into a binder or it gets entered into a system later. The problem, though, is speed and fidelity, delayed reporting, inconsistent scoring, and limited visibility to leaders who need to act when it actually matters. Digitizing the HECA tool will solve that. Guided prompts ensure observers verify the specific direct controls that matter for the energy that's present. For example, fall arrest setup, energy isolations, or spotter protocols for mobile equipment. Photo and video capture also provide evidence, and QR tags can confirm the exact asset or location. The tool can score the observation automatically, producing a HECA score that will act as a good leading indicator of SIF prevention health. And when a critical control is missing or ineffective, the workflow can be set up to trigger a stop work condition and automatically escalate to a supervisor or permit authority. You don't need to wait for a form to be submitted to intervene. We can also capture corrective actions on the spot, assign an owner, a due date, and verification steps so that we're not just documenting a gap, we're actually closing it. Roll all of those HECA observations up, and leaders can see trends, which tasks or crews frequently miss controls, which shifts or contractors show lower scores, and where to target coaching, engineering controls, or redesign. The HECA score gives you a quantitative pulse of control effectiveness long before a lagging indicator will ever show up. So far we've digitized our pre-task energy identification and our in-field controls validation. But if an event does occur, we still need objective, consistent classification to learn effectively. And that's where the safety classification and learning model comes in. So even in mature programs, unplanned events can still happen. To learn effectively, classification must first be objective and consistent. And as we mentioned, the EEI safety classification and learning model uses a decision tree that guides investigators through 4 core questions. 1, was high energy present? 2, was there a high energy incident? 3, was a serious injury or fatality sustained? And 4, was a direct control present? In our digital investigation workflow, we can embed a SIF questionnaire that uses branching logic to prompt these questions. Investigators use the system to walk them through the decision tree. And based on the responses, the event is consistently classified as either a SIF event, a SIF potential event, or an exposure or capacity, depending on whether a direct control was in place. This questionnaire would be integrated with a digital incident management system, which many of you likely already have, where we can also capture the investigation evidence, such as photos, interviews, and timelines. This fully digital approach reduces bias, it accelerates cycle time, and ensures that we're comparing like with like across sites and contractors. It also drives better learning, where we can connect the dots between the energy present, the control state, and the outcome to pinpoint weaknesses. So for example, if multiple SIF potential events show high energy with no direct control for mobile equipment interactions, that would signal a need for possible engineering barriers, geofencing, or maybe formalized spotter protocols, all of which now move us away from more traditionally reactive methods like safety campaigns and posters, which we all know have proven many times to be an ineffective corrective action. And tying it all together, we now have a fully digital thread from pre-task identification to in-field verification to post-event learning. And so now on the next slide, we'll be showing you how bringing all of this into digital dashboards will provide a clear, prioritized view of where we need to take action. So this is where it all converges. Visual dashboards that turn our energy wheel assessments, our HECA observations, and our safety classification and learning classifications into actionable intelligence. So I just wanted to call out 3 specific views that many leaders will likely care about. The first one is the SIF and potential SIF counts and trends, which can be seen on the dashboard on the right-hand side. You can read the number of SIF events this year directly from the chart and note what the trend is over time. This could help set the urgency and focus for your leadership teams. You can also see the HECA performance on the left and where we're consistently strong or weak on direct controls. The dashboard also provides energy source insights. In this example, gravity and mobile equipment stand out as the top high energy sources where direct controls were often missing or ineffective. This would be an immediate prioritization flag. And with this clarity, we can target interventions precisely. For example, for gravity, we might need engineering upgrades to anchor points, enhanced pre-use inspection workflows, or enforce 100% tie-off verification. And for mobile equipment, we may need a redesign of people to plant separation, proximity detection, traffic plans, or certified spotter protocols. And then over time, these dashboards support more preventive analytics, highlighting where SIF potential signals are accumulating so you can shift resources ahead of incidents. Instead of reacting to lagging indicators, leaders can now preempt with training, engineering, or scheduling changes where the data tells us the risk is trending. But the big takeaway here is that technology doesn't replace our SIF tools. It enhances them. It makes them faster, more consistent, and scalable, and it gives leaders the clarity to prioritize the work that prevents harm. And then with that, you're ready to connect these insights to your broader safety management processes. So we're now nearing the end of our session. I'm going to hand it over to Tanya to summarize some of the technology key concepts that we've reviewed.
Thanks so much, Farzhana. So as we've explored, adopting a technology-led approach to SIF prevention is about more than just tools and software. It's about fostering a broader culture of safety and continuous improvement. The data collected by organizations, particularly through the work of dedicated safety professionals like us, is incredibly powerful. It holds the key to driving meaningful advancements in SIF prevention. But let me say this, it's not enough just to have data. Technology and data are only as effective as the environment in which they're used in. For technology to truly work its magic, organizations need to build a foundation of collaboration and trust. This means safety information must freely flow across all levels of the organization. And when I say all information, I mean all information, the good, the bad, and the ugly. Mistakes need to be seen not as failures, but as opportunities to improve as well as to grow. Think about it. Imagine a workplace where everyone, from frontline workers to senior leaders, feels empowered to share their insights and their concerns, and yes, even their mishaps. What happens if we create that level of openness and transparency? It allows teams to learn together, adapt, and turn their shared experiences into solutions. This kind of environment encourages everyone to be part of the prevention process, and that's where the real change can happen. Now, let's not forget the human side of all of this, our people. If we want to build workplaces where safety is truly a priority, we need to invest in employees. That means providing them with meaningful training, not just the kind that you can sleepwalk through, but training that equips them with the knowledge and tools to make safer choices on the job. It means encouraging open communication and creating systems where employees feel heard and valued, where they can safely raise their concerns and they can be recognized. So where does technology fit into all of this? Well, technology acts as a powerful enabler. It helps us to organize and to analyze data. It highlights risks that we may not have spotted otherwise. And it enhances our ability to respond to incidences in real time. But what makes it even more impactful is its ability to complement the human effort. When technology and people work hand in hand, we're able to build workplaces that are proactive, not reactive. Workplaces where safety is more than just a policy. It's a practice woven into every single action and decision. The progress we've seen over the last 2 decades proves what's possible when organizations collaborate effectively. Occupational injuries have steadily decreased, showing us that meaningful change is achievable. But there's still more work to do. With a slight shift in focus and priorities, and by embracing the combined power of technology, trust, and culture, we can take the next step forward to a safer future. We, as safety professionals, can pave the way to workplaces where serious injuries and fatalities are not just reduced, but are eliminated entirely. That's a bold vision, but it's one that I believe that we can achieve together. Because when safety becomes a shared responsibility, when it becomes part of the very fabric in how we work, there's no limit to what can be accomplished. Over to you.
Great. It's a great segue. Thanks, Tanya. Okay, so as we wrap up today, we want to take a moment to express our sincere thanks to all of you for joining us. Before we dive into the Q&A, let's quickly recap some of the key points that we discussed. So first off, we talked about how SIFs need focused strategies. Traditional models like the Heinrichs period just do not cut it anymore. We also highlighted how technology is a game changer in safety, allowing us to be proactive with tools like mobile apps and data analytics. Another crucial aspect that we covered is the importance of focusing on precursors and validating critical controls. And finally, preventing SIFs can be challenging, but we truly believe it is within our reach. So if there's one thing that we hope you take away from today, it's that with the right mix of human insight and technological innovation, we can prevent serious injuries and fatalities. And by combining cutting-edge technology with strategic focus and unwavering commitment, we can turn our workplaces into environments where safety and productivity are working hand in hand rather than opposition. And together we'll create workplaces where everyone feels valued, protected, and empowered, places where each of us makes it home safely at the end of every day. So we're ready to open the floor for questions. Tanya will lead us through the questions that are coming through the Q&A panel, and I think we have one ready to go.
I'll go ahead and just read that one out. So how do we see artificial intelligence influencing safety practices and serious injury and fatality preventions in the future?
Yeah, so we had a feeling this one would come up, and we intentionally didn't address it specifically in our content because for us, AI is really an emerging technology, and it has many potential use cases across all industries. And of course, in the safety space, one area that is being explored is, of course, the prevention, where using AI to analyze patterns, predict high-risk scenarios, and support proactive interventions is a key theme. And what's exciting for us is that AI can also help engage frontline teams by making it easy to identify what it is and what isn't a SIF. And this kind of categorization is critical. AI can act as a tool to democratize safety, empowering users at every level to make better data-informed decisions. But that said, AI is not a standalone solution, and it works best when integrated with an already strong safety culture and human judgment. So our current focus remains on proven strategies and leadership-driven processes while we monitor these developments closely to see how they can complement and not replace all of the work that you all do today on a regular basis.
Awesome. Thank you.
Okay. Yeah.
Okay, so we do have a few more questions from the audience. I'm gonna just read one off to you, Farzhana. So I think one thing that makes it difficult to invest in technology is that it seems to rely on previous injuries and incidences. But in my limited experience, many times the really serious injuries are not something that have had history. So my question is, how will technology be able to predict those things when we cannot train technology to look for things that we have not yet identified? Farzhana, do you want to do this one, or do you want me to jump in?
Yeah, maybe I'll just quickly start. I think the focus, it sounds like what I'm hearing in the question is there might be some work to be done on education on SIFs and identifying SIFs in the field. And so we've introduced some tools today that may help with that. And that way that helps with getting that historical data. So first is identifying the actual events that are occurring. And so before technology can actually do anything, it needs that data, like you mentioned. And so I would suggest starting out with taking a step back in your SIF program, possibly, and ensuring that everyone understands how to recognize those high risk scenarios and trying to start to gather that data. Any additional thoughts, Tanya?
I think, you also don't need to start with years and years of historical data. As Farzhana mentioned, it absolutely helps as part of machine learning and in the AI area. But if you're looking to build a SIF prevention program, you can absolutely start from the ground up and lean into those standards that Farzhana had mentioned previously in the presentation, to really get that going and get the framework properly in place so that you're best equipped for the future in recording those incidences, and you can start. I think don't be worried that you don't have a lot of historical data. There's absolutely quite a lot that you can still do around establishing a SIF prevention strategy within your organization. Okay, we have another question. Do you have any recommendations on how to get leadership buy-in to track these? Do you want to take this one, Farzhana, or do you want me to? I can jump in.
You want to take a stab at the start? Maybe I can jump in.
For sure. So absolutely, it's you want to make sure that leadership is committed to that same vision that we as safety professionals are working towards. We shared earlier on in the presentation a recent survey completed by Verdantix, which indicated that SIF prevention strategies are very much top of mind for global organizations right around the world, right across various different industries. We're moving into an area now, and we're seeing this with our customers, certainly, where safety data is not being relegated to a particular siloed area within the organization, but really organizations that have a good track record around safety management also demonstrate that they are fiscally responsible as well. So it's really tying the two together, that understanding that an investment in safety is not just an area that's going to be kind of siloed out in a particular area, but goes right across your organization as well.
Yeah, and I think I'll just add to that, along with just having them recognize the importance of it. One of the things that I've experienced in my years in EH&S is actually having our leadership directly involved in the processes themselves. So when they're using the tools, if there's dashboards that have been built, if they're using the dashboards and they're proactively going into the dashboards themselves and seeing the results, and they will naturally see the value of the data that's coming through. And in some cases, many leaders will actually do their own field inspections and observations. So they'll be using they could potentially be using the HECA tool themselves, and then doing their own critical controls validations. And then they'll see their own data come through. So I think, to get buy-in, leadership generally, what I've seen is their own experiences coming through and then setting the tone throughout the organization. That tends to go quite a long way in what I've seen.
Great. Kevin, do we have time for another one? Okay, so I've got one here. In order to identify possible hazardous conditions regarding slips and falls or trip and fall conditions, what sources does the software use? So in our particular instance, we will have your consultant will build it for you, but we strongly rely on all of the standards that exist out there. We are a tool that is available globally, so we're plugged into what's happening globally right across multiple different industries. But we're relying really heavily on all of the established standards through the safety organizations. Great.
We have time for more?
Any final thoughts, Farzhana? We've got just probably 30 seconds left.
I think that that was it for me. I really wanted to thank everyone for their participation and their attendance today, and thank you for listening to us. And we hope that you found this session really helpful. And if there's any questions that you have for us, please feel free to reach out. And hope you have a wonderful rest of your day.
All
Thanks,
right. Well,
everyone.
excellent. Yes, no, great job, Farzana and Tanya. Thank you so much for sharing your insights and expertise. Again, sorry we didn't get to everyone's questions as we're running out of time, but all the unanswered questions will forward along to our speakers. As we close, just one more reminder about the evaluation survey we're asking you to complete. That survey will open in a different screen after the webinar. As always, we appreciate your input as it helps us improve our future webcasts. With that, we end today's Safety and Health Magazine webcast. We'd like to thank Farzana Shah, Tanya Jenke, everyone at Cority, and all of you who listened in. Thanks and have a great day.